Look around you, what do you see? Take a moment to observe your surroundings. Maybe a car is driving by, navigating through the bustling streets or speeding down a highway. Or perhaps a bird is flying in the sky, gracefully gliding through the air, searching for food or a place to rest. A dog might be wagging its tail, excitedly playing in a park or backyard, full of energy and life. Even the hands on a clock are constantly moving, ticking away the seconds, minutes, and hours of our day. All of these are examples of motion. Motion is not just limited to living beings, it encompasses everything around us. Motion is simply a change in position over time. It's everywhere we look, from the bustling city streets to the serene parks. Understanding motion is fundamental to understanding how the universe works. Scientists and students alike study the principles of motion to unlock the mysteries of our world, from the smallest atoms, which are in constant motion, to the largest galaxies, which move through the cosmos. Everything in the universe is in motion. Our planet rotates on its axis and orbits the sun, while stars and galaxies drift through the vast expanse of space. Motion is defined as a change in an object's position over a period of time. To understand motion, we need a reference point. A reference point is a fixed location that we use to compare the position of an object. For example, imagine you are sitting on a train. The person sitting next to you appears stationary relative to you. However, both of you are moving relative to the ground outside. There are different ways things can move. We call these different types of motion. One type is called translational motion. This is when an object moves in a straight line. Another type is rotational motion. Think about a spinning top. This is rotational motion. An object moving back and forth is called oscillatory motion. A swing set is a good example of this. Section 4. Newton's laws of motion. These laws form the foundation of classical mechanics and are crucial for understanding the behavior of objects in our universe. Sir Isaac Newton was a brilliant scientist who made significant contributions to physics and mathematics. His work laid the groundwork for many scientific advancements. He developed 3 fundamental laws that explain how objects move and interact with each other. These laws are still used today to solve complex problems in engineering and physics. Newton's first law, often called the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an outside force. This principle helps us understand why seatbelts are essential in cars. We call this resistance to change in motion inertia. Inertia is the reason why you feel a jolt when a car suddenly stops. Newton's second law explains how force, mass, and acceleration are related. It tells us that the force acting on an object is equal to the mass of that object times its acceleration. This means that the more massive an object is, the more force is needed to accelerate it. For example, it's much harder to push a car than a bicycle. Newton's third law states that for every action, there is an equal and opposite reaction. This law is why rockets can launch into space, and why you move backward when you jump off a boat. Section 5. Motion in our lives. Motion is an integral part of our daily existence, influencing everything we do and see. We experience the laws of motion every single day. From the moment we wake up and get out of bed to the time we lay down to sleep, motion is all around us. When we walk, our feet push against the ground, the action. This simple act of walking is a perfect example of Newton's third law of motion. The ground then pushes back on our feet with an equal and opposite force, the reaction, propelling us forward. This interaction is what allows us to move efficiently. When we drive a car, we use the accelerator to apply a force to the car, causing it to speed up. The engine converts fuel into motion, demonstrating the principles of energy and force. When we apply the brakes, we are applying a force in the opposite direction, causing the car to slow down. This is an example of how forces can be used to control motion. Understanding motion is not just important for scientists and engineers, it is crucial for everyone, as it helps us navigate and interact with our environment more effectively. It helps us understand the world around us and how things work. From the natural movements of animals to the mechanical operations of machines, motion is a fundamental aspect of life. By studying motion, we gain insights into the principles that govern our universe. This knowledge